Our field of research is environmental chemistry, really the chemistry of the environment. Chemicals have personalities, and we interrogate those personalities to determine where do they go, how fast do they change, what do they turn into, how they may cause harm to the ecosystem or to individual organisms within that ecosystem. Really, we use chemical pollutants as chemical probes. What are they doing in the environment? That helps us interrogate the environment, determine what can happen in the soil, what can happen in water, what can happen in air, how fast, what are the mechanisms. The thing that we got particularly excited about was explaining why polar bears and humans are the most contaminated organisms in the world with perfluorinated acids. Specific examples of which nobody knew actually were chemical pollutants. And so that's a eureka moment with well, how did that happen? We breathe in these volatile chemicals inside this office, for example. They could be off-gassing from the carpet if the carpet was treated, or our clothes, very common. These things can be inhaled, and we will metabolically convert them from the precursor alcohols into the perfluorinated acids, the final compounds that no longer degrade. And they stick around in our bodies for 3, 4, 5 years, so they tend to reach relatively high concentrations. So we've learned what the source of those are. They were waste products that industry nor government knew were there, so they didn't know to regulate them. So we discovered them in the atmosphere, worked them back to where they came from, and following that, the EPA, Environment Canada, passed regulations and got industry to step up and clean up their materials so that the final use products are actually quite clean and they're no longer off-gassing those precursors. So we are endeavoring now at designing much greener alternatives, chemicals that will impart the surface properties that fluorinated chemicals do, but also when they get released in the environment that Mother Nature will just chew them up back to their original constituents. That would be a beautiful thing.